All right, I'm doing another Sudoku today. This one was sent to me by PjotrV, I think is how you pronounce that. And it's called Mark of Zorro. It has 2 stars out of 5 rated for difficulty on Logic Masters Germany, so hopefully it won't be too much trouble for us. Let's see, I'm going to pull it up here in F Puzzles. I'll leave a link in the description to where you can try this puzzle yourself. There's a lot of rules, but they're all pretty standard, I think, it looks like. So, obviously, it's the mark of Zorro because this Z-shaped arrow here. Rules are digits along the long arrow, that's the Z, must sum to the total here. So this is like normal arrow stuff, but it's a 3-digit total. So if this was, 1, 2, 3, then the total of the rest of these along the arrow would have to be 123. All right, gray line is a palindrome, reads the same both directions. So I think that's this gray line here. There's several gray lines, but the arrow is the longer, thinner line. And these look like the thermometers because they have the bulb at the end. So this one is a palindrome. It has to be the same forward and backwards. In cages, digits must sum to the small clue in the top left corner. So normal killer cage stuff with these. These have to sum to 12. Both of them. Along thermometers, digits must increase from the bulb end. So yep, thermometers, normal thermometer stuff. Black dots mean that the ratio of 2 connected cells is 2. So these have to have a ratio of 2, like 1 and 2. The white dots mean that the difference of the 2 connected cells is 1. So the white dots have to be consecutive digits, which could also be 1 and 2. So that's normal crop key stuff there. And I normally say crop key dots, but I recently learned that I think crop key is Polish for dots. So you're essentially saying dots, dots when you say crop key dots, but I'm still probably going to say that a lot of times because I'm just used to calling them crop key dots. But all right, I'm going to give it a try now. If you want to try it yourself first, pause the video and go give it a shot because hopefully I'm going to be spoiling things. Okay, so what are we going to start with here? I mean, the big arrow seems like maybe we can limit things, but we know, well, I know that a 12 cage of 4 cells has to have a 1 and a 2 in it. And you can figure that out. You can look it up, like I've done before on certain puzzles. But you can also figure it out. Just think about, could it not have a 1? So the smallest you could do without a 1 is 2, 3, 4, and 5, which sums to 14. So you have to have a 1 in the cage. Now, could you not have a 2? Well, 1, 3, 4, 5 would be the smallest you could do without a 2, which is 13. So, in fact, you have to have a 1 and a 2 in both of those. They're actually 1, 2, 3, 6, or 1, 2, 4, 5 are your options. So those are pretty limited. And in fact, let's see, I'm going to write those in. 1, 2, 3, 6, 4, 5. In fact, these two have to be 1 and 2 because you can't put 1 and 2 in these 3 cages. Or, you have to have a 1 or a 2 over here and a 1 or a 2 over here. So these two are also going to have to be 1 and 2, which means these can't be 1 or 2. But it could be, and one of them's going to be 3, 6, and one's going to be 4, 5. But we don't know which ones yet. Let's see, we could probably do something up here where we have dots kind of connected, especially the 2 black dots. That's going to have to be, so you can't do 3 and 6. Normally 3 and 6 can be on a black dot, but when there's 2 of them like this, if you went 3, 6, then you'd have to have a 3 again, which obviously you can't do. So those are going to have to be 1, 2, 4, and 8, and it's going to be 1, 2, 4, or 2, 4, 8, or the other way around. So this one's going to have to be 2 or 4. And this one, since it's on a thermometer, Can't have a 1, and this one can't have an 8 because it's at the bulb of the thermometer. Nice. Okay. So does that tell us 1, 2, 4, 2, 4, 8? Yeah, this one can't be 4 because it would have to be 4, 2, and you'd have to have a 1 there. So 1, 2, 4, 2, 4, 8. This one can't be a 2. Don't think we can go any farther than that, though, with that part. Um, and this is, I mean, 3, 5, 7, or 9. There's quite a few options there. But this can be almost anything that's bigger than 4. I mean, if this ends up being an 8, this will have to be a 9. But if this is a 4, this could be 5, 6, 7, 8, or 9. So that doesn't tell us much. What else can we do? I think we're going to have to look at this arrow. So I know that this part of the arrow equals 45 because it's a whole row, and a whole row in a Sudoku always equals 45. This one will be 45 minus the digits we put in here. So if it was 1, 2, 123, 1, 2, 3, it would be 45 minus the 6. These would be 39. And I know that these 3 are the same as these 3. So that's going to be, if this sum was x, that would be 2x. Don't really know what those are yet. They could be as small as 145, which would be 10. They could be as big as 289, which would be 19. That's quite a range, 10 to 19. Well, let's just see. I'm curious if this can even be a 2. Can we get to 200? So 45 across here. What's the maximum the diagonal could be? Let's see. It would be 789. 789. 789 is 24, so that would be 48. You're double counting this corner, though. So if we're trying to maximize it, we would put the 7 there. So we're double counting the least amount. So 48, and this would be 38 then. So that's 70. It's 96. This we said could be as much as 19. 96 plus 19 is 115. I think close to 115 at least. And yeah, so even if we had all 45 of row 1, there's no way you can get to 200. So this has to be a 1, which is going to give us the 2, 4, 8. Means this is a 7 or a 9. Oh, this is a 9 because of the thermometer. So that's a 7. This is an 8 because of the crop key dot. All right, now we're making some progress. This, well, we need, what, 1, 3, 5, and 6 still? These can't be 1. And because of the thermometer, we can do that. 3, 5, and 6. This is 6, 7, 8, or 9. This has quite a few options. Just has to be bigger than the 5. So this can't be 2 or 1. This is at least 3. So I think I was at, what, 115 plus. I mean, these right here are going to be 42. 115 plus 42 is 157. So the maximum I can really get to, and that's assuming you're counting these in the total. So 157, I don't think we can probably even get to 5. Because this would have to be 153. Yeah, and you'd be subtracting 8 from that 157. So this can't be 5. So it's a 3 or 4. So it's 130 or 140 something. We know that much. And what about this black dot right here? Can this be Can this be 1, 2, 4, 8? Because it can't be 4, 8, and they can't have a 1. So this could be 2, I suppose. 2, 4. That's still possible. Otherwise, it would have to be a 3, 6 pair. Yeah. Okay. Um. Well, this bit down here is not helpful at all. Obviously, this part of the arrow, because this equals 45, so that's not going to give us anything. We've got a chain of 3 white dots here, but that could be, I mean, that could be almost anything right now. Okay, so it's got to be. Oh, of course. Yeah, right in here. We've got. So one of these is 3, 6, and one of them is 4, 5. But we don't know which is which. But what we do know is that these 6 cells are 1, 2, 3, 4, 5, 6. So these are 7, 8, and 9, which is what we said the maximums were. So that's not too surprising. This one can't be 8. And actually, since it has to be consecutive to this, the only way to make that happen is a 6 and a 7. So these are not 7. These are not 7. This one is a 7, which is good. Now we know the overlap amount here. Because if you'd go row 1 plus the diagonal plus row 9, you're counting the 2 and the 7 here twice. So we now know that these 8 cells equal 38 because it's 45 minus the 7. So yeah, I think we can figure this out now. So 38 plus, we said these are 48. So that's 70. That's 96. This was the maximums that we were calculating earlier. 96 plus the 19, so 115, right? 96, 106, 115. Yeah, 115. Okay, 115, and these 7 cells are going to equal 42 because it's the 45 minus the 1 and the 2. So 42. So let's add the 42 to 115. That's 157. Right? 157. So the whole arrow is going to equal 157 minus the 2 digits we put in here. So, and this is a 3 or a 4, so it's going to be, if it's a 4, we're at 153 minus this digit. So can we do, is that right? 153, so 147? Is that possible? 147. Let's see. This is 38 plus 48 is. Oh, wait. No, hold on. 38. I did the math wrong. 38 plus 48 is 86. 48, 86, not 96. 86 plus the 19 is 105. 105. Okay. That doesn't really affect what we did earlier, getting the 1 here, because it's actually lower. It's even harder to get to 200. But we're at 105 plus 42. So 147. So yeah, so this has to be a 3. And so that's okay, 147 minus the 3 is 144. So yeah, so 7. That's going to get us to 137. 144 minus the 7. So 137. Now we know that these are not 3 and 6 because we've already got the 3, so they have to be 2 and 4. The 3 there is going to give us a 5 and a 6. This has to be 8 or 9. It can't be a 7. We've got 4, 8, and 9 there. These are 1 and 3. All right, getting some progress here. This is good. The 2 there gives us the 1 and the 2 over here, which means there's not a 2 in here. And the 6 here tells us that this is the 1, 3, 6. So those are 1 and 3. This has to be the 2, 4, 5 over here. This one can't be 2 because of that 2. Okay, now where do we look? 3. What can we do here? Can we limit this? It could be 1, 2, 2, 3. Can't be 3, 4. Can't be 4, 5. 5, 6. Can't be 6, 7, 7, 8, or 8, 9. So it's 1, 2, 2, 3, or 5, 6. Ah, okay. There's a 5, 6 here. If this was a 5, 6, we'd have to have 5 and 6 right there. But then what's going to go in this cell? Because 4 and 7 are already taken. So this would then have to be 5 and 6 to go with for the consecutive. So we can't do that. So this can't be 5 and 6, which means it's a 1, 2, 3. That gives us a 1, 2, 3 triple. So we have 5, 6, and 8 across here. This one can't be 6. So there's a 6 here. 5, 6, and 8. This one can't be 6 and it can't be 4, so this can't be a 5. This can't be 7. It could be 5, 6 or 8, 9. It's either 5, 6 or 8, 9, which means this one is also 5, 6 or 8, 9. So 5, 6 or 8, 9. So in that, like that, in that order. So we've got 6, 8. This 6, 8 pair gives us a 5 over here. 5, 9. So this is 1, 3, 6. No, not 9. 1, 3, 6, 7. Sorry. Across there. That should be a 7 in the middle there. Are both of those still possible? I think so. The 8 and 9 here. 5. Okay. What else can we do? Maybe something with these white dots down here. Are they more limited now? Or maybe the black dot. Maybe we should look at the black dot because we've got a 2 and an 8 right here. So these can't be 3 and 6 because we've got a 6 in both columns there. So you can't do 3, 6. So this is 1 or 4, which means this is 2 or 8 because it's either 1, 2 or it's 4, 8 or 4, 2. Now, this is a series of 4 consecutive digits, but it could go in either direction. But you can't do 1, 2, 1, 2, 3, 4 does, well, 1, 2, 3, 4 would work this direction, I think, if you had 4, 8. 1, 2, 3, 4. No, it would not. You can't put 2 and 3 right here because we already have 2 cells in the column that are limited to 1, 2, and 3. So if you put 2 and 3 right there, you'd have 4 cells using only 3 digits. So you can't do 1, 2, 3, 4. 2, 3, 4, 5 would have to go this direction because of the 5. But 2 would make this 8, 4. So 2, 3, 4, you'd have 2 4s. You can't do 2, 3, 4, 5. Can you do 3, 4, 5, 6? 3, 4, 5, 6. I think so. 4, 5, 6, 7. Yeah. Yeah, there's quite a few options there. Okay. That's not the place to look then. These white dots aren't going to be very helpful. And this arrow, we've already done what we can with this arrow. And now it's just a normal row. What else? What am I missing? I'm missing something. Is it something with the 9s and 8s here? Because they've got to be... So I can see that neither of these can be an 8 or a 9 because these are different, right? 8 and 9. These have to be 2 different digits. But these two have to be the same because of the palindrome. And these two have to be the same, which tells you that these two are also different. And these two are different. So since one of these is an 8 and one of them is a 9, you can't put an 8 and 9 there. Same deal with these two on that cell. So these cannot be 8 or 9, which this one couldn't be 9 anyways. But this one, so 9, 8, 7, well, we couldn't do 9, 8, 7, 6 anyways. But we can't do 9, 8, 7, 6 because this can't be an 8 or a 9. So this can't be, we already decided it couldn't be 1, it couldn't be 2. Could be 3, I think. 4, 5, 6. Could it be 4, 5, 6, 7? Yeah. Couldn't be 4, 3, 2, 1, we decided. This can't be 5, 6, or 7. And it can't be 9. Can it be 8, 7, 6, 5? Yeah, so this has to be a 3, 4, or an 8. If it's a 3 or a 4, it's going up. If it's an 8, it's going down. So let's see. This could be 3, 4, 5, 6. 4, 5, 6, 7, or 8, 7, 6, 5. Oh, that gives us a 5, 6 right there. That's somewhat limited. 5, 6, 7, 4, 5, 6. Okay, where else do these mean you can't put an 8 or a 9 right there? Oh, yeah, yeah. I should have seen this up here. Okay, up here, we said this is 5, 6, or 9, 8. If this was 9, 8, that would have no options. So this can't be 9, 8. It's 5 and 6. Okay. That means that's 9, 8. I should have spotted that. All right, what does that do for us, though? 6, 9, 8. Maybe nothing. Does that do anything for us? 9, 8. So what about these here? So we know it can't be 1, 2, it can't be 2, 3. Could be 3, 4. Could it be 4, 5? Yep, if it was this direction because of the 5. Can't be 5, 6. Can't be 6, 7. It can't be 7, 8 because you can't have a 7. It can't be 8, 9. So this is a 4. Okay, 5, 5. Now, where do we go from there? 4, 4. There's a 4 down here. All right, I'm going to look back down at these options here. Is there... Oh, 6, 7 right here. Clean up the pencil marks. What am I doing? Now we have a 1, 3 pair, so this can't be a 3 anymore, which means this can't be 4, 5, 6. So now, whether this is 8, 7, 6, 5, or 4, 5, 6, 7, this is a 6, and this is a 5, 7 pair. So this is not a 6, which means this is the 6. This has to be the 7, which gives us the 5 and the 7. So this 5, 6, 7. So this has to be the 4. Good. 4, 5, 6, 7. So 1, 2, 3, 8, 9. Let's see, there has to be a 7 up here. What do we have left over here? This is oh, hold on. That 5 there gives us the 3 there. Okay, now what do we have left over here? 7, 8, 9, and this one can't be 7 or 8, so it's a 9. And that makes this the 7. This is the 8. Now we've got our 8s and 9s there. That 8 is going to give us this over here is a 2, 1. So 9 has to be in one of these two. We've got 1, 3, 8, and 9 down here. These can't be 9s. Let's see, what else? This one can't be a 9. This one can't be an 8. The 1, 3 pair means this can't be a 1, 3. So we've got an 8, 9 again there. All right, where do we look now? There's got to be, oh, the 7 has to be here because that's 7. What are our options here? We can't do 1, 2, 2, 3. We could do, can't do 3, 4 because we have a 1, 3 pair already in the row. Could do 4, 5, 4, 5, 5, 6. Yeah. Can't do 6, 7, 7, 8, or 8, 9. So this is a 5 with a 4 or a 6. 5, that puts a 5 up here. 4, there's a 4 down here. There's a 9. Oh, the 9 has to be here. Because all these 9s. The 9 down here puts a 9 there. Now, what do we have left in the column here? 3, 4, or in the row, 3, 4, and 5. This one can't be 5. This one can't be 3, and that one can't be 4. All right. 2. There has to be a 2 over here. 2. These 2s. Has to be an 8 down here. I feel like we should be able to get the 8s and 9s, but I can't quite see how to do the last one here. Because 9s are in there and 8s are in both of those, or even here. We have all the 7s? No, we're missing this 7 right here. There we go. Which gives us the 2. 5, 6, and 8. And this one can't be 8. This one can't be 5. Oh, that one can't be 8. So this is the 8. Yep. That gives us a 5, 6 pair up here. So we've got 1 and 3 left in the row. Our 1, 3 pair, our friend that we've been finding everywhere. These are 6 and 8 down here. This has to be the 4 and the 6 because of the 6 up there. And this one down here, that's probably been sitting there forever. Which means these are 2, 3, that's a 1, and a 3, and a 1. 2 and 3. Is there any way to get those? No. Okay, the 1 up there gives us the 3 and the 1 here. That 1 there. So this is not a 1. So 1 there, and a 1 here. Okay, what's left up here? 4, 5, and 6? 2, 3, yeah, 4, 5, and 6. And this can't be 4 or 5. So this is the 6, which is going to give us 5 and 6 and 4 and 3 and 5, and we need 3 in the column. This is 1 and 2 for the column. And what's left over here? 2 and 4, and this 4 here gives us the order of those, and that 2 now gives us the 1 and the 2 over here, which puts a 1 right there. We need 5 still for the box in the column there. And then we ought to be able to disambiguate the rest, right? The 3. So that gives us an 8, 9 pair here, which gives us a 6 and an 8 and a 3. And that 3 will give us the 2 and the 3, which will give us the 2 and the 4. And that 4 is going to give us the 8, the 9, the 4, and the 8, and the 9. There we go. The timer turns green, which means we're done. We've got it right. So that is the Mark of Zorro by PjotrV. That was a fun puzzle. I like the figuring out the long arrow was kind of cool, and I should have probably seen the 7, 8, and 9 a lot earlier in here with this. So sometimes puzzles with lots of different constraints like this can feel a little bit mishmash and, kind of like it's all thrown together. But these actually worked together. We couldn't get the arrow until we'd done these cages, and we also had to use the crop key up here to get these digits. So they all kind of work together. And then once we got the arrow, it was a lot of sudoku and crop key to kind of finish it off, and keeping track of pencil marks, which I'm not very good at sometimes. And yeah, that was a fun puzzle. Not too difficult. 2 out of 5 seems about right. That's what it's got on Logic Master. So thanks, Piotr, for sending that in. And I'll see you guys again soon with some more puzzles.